I'm Jade Abdul Qadir, and I will be showing you how to construct the circuit in Multisim as well as measure R2 on the bench.
Hey there, my name is Kevin Andrews. I'm going to be presenting how to measure across the voltage source.
Hello, I'm Lorenzo. I will be measuring R2 on Multisim, all the measurements on R2.
And my name is Tyra Monte, and I'll be measuring the voltage source on the bench.
Hi, it's Jade with Team 1. We're going to construct our Multisim circuit. First, go to Place, Title Block, and hit the default title block and put it in the bottom right-hand corner of your Multisim. We're going to title it AC Team Project. Under Description, we can just call it AC Circuit with Oscilloscope. And for Designed By, we're just going to say AC Team 1 and hit OK. Next thing we're going to do is go to Place Sources, and we could go to Power Sources and hit AC Power for VRMS, or Signal Voltage Sources, which is what we're going to do, and hit AC Voltage to put in Volt Peak. Then we're going to go back to Power Sources and put in our ground. Next, we're going to go to our volt source, and we're going to change our voltage to 3 volt peak and our frequency to 6 kilohertz. And then under label, you can just rename it from V1 to VIN. All right, now we're going to go to Place Basic, and we're going to go down to Resistor. And you can just type in for R1, it's going to be 680 ohms, and place it in your circuit. And then we're going to do 2.7 kilo ohms and place that as well. And hit close. And then you can just rotate 90 degrees your R2, because we're going to be putting these in series. All right. And now we're going to go and we're going to put in our oscilloscope. So on the right hand side of your Multisim, 4th block down, you will see the oscilloscope. Just click that and bring that in the top right hand side of your Multisim grid. And then we're going to go to Place Indicators, Voltmeter, and we're going to bring in 2 vertical voltmeters, put them beneath R1 and to the left of R2. Hit close, and then we can adjust R2 if we need to, make some room so we can see everything. Our first voltmeter we can name VN underscore RMS, and then we're going to go to value, and we're going to change it to AC rather than DC. We're going to do the same thing for the second voltmeter, AC, and then this one we're going to call V2 underscore RMS and hit OK. And now we wire. So first thing, starting with our volt source, VN, we're going to put the positive to the positive of our R1, and then the negative of R1 is going to connect to R2 since we're putting them in series, the positive of R2, and then we can connect our VN negative to ground and our R2 negative to ground as well. And we can go ahead and change the the net color to a different color to differentiate the ground from power. All right, and then we're going to continue wiring. So our VN RMS voltmeter, the positive will go to the positive VN, and the negative will go to ground. And then we will do the same thing on the other side with V2 RMS, but in respect to R2. Channel A, positive of the oscilloscope, will also connect to the left of the R1, and then positive of B, channel B, will be the connecting to the positive of R2, while the negative connects to ground for both channels A and B. And you're done.
Hey there, my name is Kevin Andrews. My team consists of Jade, Tyra, and Lorenzo, and we will be showcasing the fundamentals of a resistive AC circuit. Jade and Tyra will be explaining the benchtop portion of the presentation. Lorenzo will be demonstrating our Multisim measurements across resistor 2. and I will be demonstrating our multisim measurements across the voltage source. A brief overview for what I'm going to be going over. 1, how to set the circuit up in multisim. 2, the components that will be used. 3, how to take measurements across the voltage source. And 4, the 2 methods for taking those measurements, old school versus new school. Setting the circuit up, our components will be set up in a series relationship with each other, while our measuring tools will be set up in a parallel relationship across the AC voltage source. Our circuit will consist of our AC voltage source, set to 6 volts peak to peak to 6,000 hertz. We're going to have our ground point. Our 2 resistors, one set to 680 ohms, the other set to 2.7 k ohms. Our oscilloscope to measure peak to peak voltage and our period/frequency. And our digital multimeter, which will be measuring VRMS. I've included a few formulas here for how to convert peak to peak voltage to VRMS, and the same for period over to frequency. Now, what is old school versus new school? Old school is calculated by counting the divisions, which are the little squares on the oscilloscope display, and multiplying that by their scale. While new school is calculated just by reading directly off the virtual display. It's a lot more straightforward. That being said, let's jump straight into our circuit. I've already set this up, not to waste any time, but let's quickly go over it. Our voltage source is set up to 3 peak voltage and 6,000 hertz. This will give us our 6 peak-to-peak voltage, and as you can see from the digital multimeter, our VRMS is sitting roughly around 2.12 VRMS. Our circuit is solely resistive. There are no capacitors or inductors present. I've recorded our values here just for the visual aspect. To keep this brief, to measure peak-to-peak voltage, we're going to be relating our parallel relationship oscilloscope. I'm going to pause our measurements just for simplicity's sake, right? I'm going to scroll roughly here. We will be measuring with our 2 cursors. Set the number 2 cursor before the first one, as you can see, number 2 and number 1. Set the 2 to the peak and the number 1 to the valley. Number 2 goes to the Y max, number 1 goes to the Y min. And this number right here, we're getting about roughly the 6 volts peak to peak, which is what we're actually looking for. To measure VRMS, this one's a bit more obvious. I've actually covered it at this point already. We have our digital multimeter set up in a parallel relationship across the voltage source, with it also set to AC mode. If this isn't set to AC mode, you're not going to get what you're looking for, but we're getting our 2.12 VRMS. You can also calculate VRMS through the formulas on the PowerPoint. Take your peak-to-peak voltage, divide it in half, and then multiply it by the square root of 2, which is about roughly 0.707. Fairly straightforward. To wrap things up, period and frequency. To do this, move your number 1 cursor before the number 2. Set them roughly before the X intersect here. Set both of them about roughly there, and set their Y values to 0. Y values to 0. And this number right here is going to be our period, 166.7 microseconds. Now, once again, to double back onto that formula page, the way that you'll be calculating our frequency is I've kind of gone through the effort of plugging our numbers in. You take 1 and divide it by the period. So 1 divided by 166 microseconds gives us roughly 6,000 hertz, which is exactly what we're looking for. This will conclude the multisim measurements for our AC circuit across peak-to-peak voltage. Across the voltage source. Thank you very much.
Hello, my name is Lorenzo, and I'm going to be going over resistor 2. So first, let's go over volt peak to peak. So to get volt peak to peak, we're going to set this cursor to Y max, or to the peak of the wave, and then this one to the valley of the wave. Oh, not that one. There we go. And then the volt peak to peak would be this number right here, 4.785 volts. If I wanted to solve the old school way, I would count my squares. So I would say 1, 2, 3, 4, and not, this isn't half and this isn't half either, but it's almost there. So I would say like 4.8-ish. But but adding that together, it's pretty close to 4.7. So that's how we would do volt peak to peak. Then let's move on to VRMS. To get VRMS, I use the voltmeter right here. Yeah, so that's how I solve for it. The other way to do it, right, the old school way, is to calculate for it. So I would use volt peak to peak. I would use volt peak to peak. And go ahead and go 4.785. And then divide that by 2. And then multiply this by 0.707. And this would give me approximately the same number, or almost exactly the same number. So now that I've done VRMS, we can go over time. So to do time, I will set my cursors to the Y value for one full cycle. 0. And then set this Y value to 0 as well. Oh, okay. Make sure you select it first. And so my time would be this number right here, 166.667. And then I will solve for frequency. So the new school, obviously we have our voltage source, and our voltage source tells us our frequency. We select our own frequency, which is 6K. But if I wanted to solve for it using time, I would just go ahead and pull up my calculator one more time. I would go ahead and go 1 divided by 166.667 microseconds. And so I would want to multiply this by, let's do that again. Let's open it up one more time so I can use parentheses. We'll go 1 divided by parentheses 166.667 times 10. Oh no, I meant XY. Oh, do it one more time. Okay. 1 divided by parentheses 166.667 times 10 to the 6 negative, close my parentheses, solve it, and I get 5,099.98, so almost 6K. And yeah, that's how I would solve for frequency. Thank you so much.
Hi guys, my name is Tyra, and I'll be measuring on the bench the voltage source. For this circuit, our first resistor is going to be a 680 ohm. We're going to place it on the breadboard with one of the legs on the dotted red line. We're going to take our resistor 2, which is a 2.7 kilo ohm resistor, and we're going to place that in series to the first resistor, leading the bottom leg on the ground blue line. Once the resistors are placed, we're going to take 2 short wires and place one where you would power and the other one where you would ground the breadboard. Once we've set up our circuit on the breadboard, we're going to move on to our alligator probes from the multimeter and grab the function generator probe. And we're going to connect the positive wires together And then we're going to take our channel 1 oscilloscope and grab the hook, which in this case is the positive, and connect it. We're going to connect all 3 positive wires together. We're also going to take all the negative cords from the alligator probes, the function generator probe, and the oscilloscope probe, and connect all 3 of those together. And this is how we're going to measure the voltage source. Make sure that everything is connected before we turn on the function generator. We want to make sure that the power source has the right settings. So we're going to input 6 kilohertz for frequency. Scroll all the way. There we go. 6 kilohertz. Once the oscilloscope is on, we're going to let it run on auto to let it refresh. We're going to go ahead and turn off channel 2 because we are not using channel 2 at the moment. We're focusing on channel 1. We're going to go ahead and scale in our channel 1. And we're going to first measure our period time. We're going to click on time on the period, and that is going to give us 1.66 microseconds for our new school recording. Now for old school, we're going to go ahead and scale it in, make sure we are able to see the squares and count them. We're going to try to align, and we're going to count from the first zero crossing to the second zero crossing. Okay, so for our old school method, we're just going to count squares across. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 divisions. So we're going to take our calculator. We're going to input 8 divisions, and we're going to multiply that by the times of each division, which on the oscilloscope says 20 microseconds. So we're going to input that into the calculator. 8 times 20. EE to the negative 6. We get that number, which is equivalent to 0.0016 or 1.6 microseconds. Moving along, we are going to measure our frequency. So we're going to go time, scroll down to frequency, input it, and we get a roughly 6.01 hertz. For our old school method, we are just going to take the inversion of our period time, which was the 8 times 20 e to the negative 6, which gives us 6,250 hertz. Now we're going to move right along, and we are going to measure our VPP, our peak to peak. We're going to go voltage, scroll down to VPP, and go ahead and input that, and that white button clears out the measuring tool so we can see our measurement, which is 6.08 volts for our new school recording. Now for our old school recording, we're going to make sure we want to scale. We're going to pick a peak, scale it in, and once we have it to our desired location, we are going to count the squares on the vertical. 1, 2, 3, 4, 5, 6. Alrighty, and we are going to multiply that by the voltage of each division or each square. So we're going to do 6 times 1, which is 6. So it's 6 volts. Now onto our VRMS. We are going to we're going to press measurements again. Clear measurements, so we have space to see the measurement for VRMS. Click voltage, scroll down to VRMS. Input that, and we can see that we get roughly a 2.61 volts. For our old school method, we're going to take the equation of 0.707 multiplied by our VP, which is our VPP, divided by 2. In this case, 6 divided by 2, which gives us, as an old school method, 2.12 volts. Thank you so much. And Jade, in the following clip, is going to show you measurements across R2.
Hi, I'm Jade. Since Tyra went over measurements across voltage input last time, we're going to be looking at measurements across resistor 2. First thing we're going to do is add 2 wires to our circuit, the first one between our resistors and the second one connected to the ground at the bottom of the breadboard. Next, our function generator, which should be off, we're going to take the probe, and the positive goes to power and the negative will go to ground. Now we're going to take our DMM probe, positive, and connect it to the right of R1, which should be 680 ohms. And we're going to take the negative DMM probe and connect it to the bottom of resistor 2, which should be 2.7 kilo ohms, or 2700 ohms. Now we're going to take our channel 2 oscilloscope probe, and we're going to connect the negative to ground to the wire at the ground at the bottom of the breadboard, and the positive to the wire between resistors 1 and 2. And we're just going to make sure that we have good contact with the wires and that nothing's falling or disconnecting. Now we're going to turn on our function generator and our oscilloscope. Make sure that your function generator is still at 6 kilohertz, our selected frequency. Press auto on your oscilloscope and turn off channel 1 since we are only going to be observing channel 2. Now for our period, we can measure it 2 ways. First, with the new school method, so you'll hit measure for channel 2, select time and then period, and it shows 168, maybe 167 microseconds. The other method would be our old school method of counting squares. So adjust the scale as needed to make it easier to see your divisions in comparison with your sine wave, and just count the squares along the horizontal axis since we are looking at time. So it might take a minute. You can adjust your scaling and adjust the position using the knobs on the oscilloscope to make it as clear as you can when counting squares. It looks like there's about 3.4 divisions times 50 microseconds, which would be times 50 e negative 6. So we get 1.7 e to the negative 4th, or 0.0001 seconds, which is 170 microseconds. It's very close to our new school method result. Now for frequency, we're going to go back down to time and just select frequency, and we see that it's around 6 kilohertz. For old school, we'll take the inverse proportion of our period, 1 over t, so 1 divided by 1.7 times 10 to the negative 4th, and it's nearly 6 kilohertz. It's less accurate than the new school method, but it's very close and it's a good estimate. Now we'll look at the voltage. So click voltage, then voltage peak to peak. Now there's quite a few measurements left at the bottom, so if you look where all the gray buttons are, you can see on our measurement menu that there's a button for clear, and you can just clear out the old measurements to make room for the new ones. And then we'll return to voltage and then scroll down to voltage peak to peak. And now we can actually see our measurement. So our voltage peak to peak is a 4.88 volts according to the new school method. Old school will do the same thing as we did before, which is counting squares, but this time along the vertical axis. So we line it up and we count. So it looks like there's 1, 2, 3, 4, almost 5, maybe about 4.7 divisions. And then this time, it's really easy. Our divisions are by 1 volt, so 4.7 times 1 volt equals 4.7 volts. So again, very close to our new school measurement. The last thing we're going to look at is VRMS. So new school, we go back to voltage, scroll down to VRMS, select it, and we see that it says 1.66 or so for our VRMS. Old school, we're just going to use the formula, so 0.707 times half of our volt peak to peak, which is 4.7. We get 1.66 VRMS, which is about the same that we got with new school method. And that's it.